What is it like to watch humanity's top paradoxes? First, the Penrose triangle. This is known as the most impossible form, a classic of visual disparity. It clearly looks like a triangle. It feels like every angle is right, with 3 pillars joined end to end. It looks completely incredible, but it does not exist in 3-dimensional space. What you see is just an illusion formed by spatial misalignment. Because your eyes deceive you, it naturally looks a bit complex. Change the angle slightly, and it becomes clear. A famous variant similar to the Penrose triangle is called the Penrose stairs, proposed by mathematician Roger Penrose and his father Lionel Penrose in 1958. It has no highest point, nor a lowest point. Once you step onto these stairs, you will fall into an endless loop, and you will never reach the end. This so-called visual illusion reveals human visual limits and the subjectivity of perception. It challenges our understanding of space and depth, but also forces us to re-examine perception and cognition in the real world. Second, Zeno's paradoxes. Why can't the world's fastest runner catch up with a tortoise? Achilles was a hero skilled at running in ancient Greece. When racing a tortoise, say it crawls 1 meter in 5 seconds, while Achilles can run 10 meters per second. To be fair, Achilles gives it a 100-meter head start before chasing after it. Yet mathematician Zeno believed that Achilles would never catch the tortoise, for when he runs 100 meters, it has crawled 10 meters. Achilles must start chasing the tortoise again. But after Achilles finishes running 10 meters, it has crawled another 1 meter, looping like this forever. Time and distance divide infinitely. This tortoise will create countless starting points. It can always, before the end point, create a distance, no matter how small the gap. As long as the tortoise moves, Achilles will never catch up with the tortoise. This is what can fold space in physics. Zeno's tortoise. Why Achilles can never catch the tortoise is due to Zeno dividing time infinitely, and there's always a shorter time interval. This seems to be a sophistical paradox, but it questions the nature of time, wondering whether a minimum time interval exists. Thousands of years later, that the birth of quantum mechanics solved this puzzle of Zeno's. In quantum mechanics, the Planck time is the shortest time interval in the universe. Similarly, the shortest unit of length in the universe is called the Planck length. From this perspective, the tortoise cannot make infinite starts. Instead, after a short time, it will reach the scale of Planck time. This is the exact moment Achilles catches up with the tortoise. In fact, Zeno's tortoise matters for human exploration of the nature of time. Perhaps in the distant future, we can build a time machine to travel through time and space. Third, the wheel paradox. This was proposed by the Greek philosopher Aristotle. A disk features 2 concentric circles of different sizes. When the large circle rolls once, the small circle also rolls once. But the problem is, their circumferences are clearly different. Why match distances? Over 2,000 years later, that Galileo proposed an ingenious method. Through the analysis of polygons, a perfect explanation was finally provided. Simplify the 2 circles into polygons and roll them, and paint the edges with ink to see the tracks of their movement. The large polygon's track is a continuous line, while the small one's track shows many blank gaps intermittently. By increasing the number of sides, you will find that the gaps of the small polygon grow smaller. Here you can see where the problem lies. When 2 circles of different sizes are rolling, in fact, only the large circle rolls, while the small inner circle just follows its rotation and slipping at the same time as it rolls. It means that the gaps generated when the small polygon rolls are traces of slipping. Colloquially, the large circle is rolling, while the small circle scrambles, slipping along. Fourth, the black hole life and death paradox. Alice and Bob are 2 astronauts. During a space mission, the 2 approached a black hole. Suddenly, Alice's thruster went out of control. She was drawn by a black hole, flying toward it. Nearing the event horizon, the slower time passes. In Bob's eyes, Alice's movements became slower and slower. She turned back to smile at Bob, only to see her smile freeze, permanently like a photograph. However, Alice faced a completely different scene. Pulled by gravity, she flew toward the black hole faster, torn into elementary particles by massive tidal forces, vanishing into the eternal darkness. This is Hawking's black hole paradox. It shows a black hole's physics. Since a black hole's mass and gravity are extreme, even light cannot escape from it. Once a person approaches it, their speed mirrors the speed of light. According to relativity, since time and space are relative, the scale of time is also different. For people at different speeds. For Bob, far from the black hole, the space-time around him is very weakly affected by gravity. To him, time is a straight line from the past to the future. Therefore, the black hole and Alice that he sees are both in a static state. On the other hand, for Alice, as she nears the black hole, it causes the light she emits to take longer to escape the black hole. Thus, the light Bob receives on the ship slows down until it vanishes. Therefore, Bob will never be able to see the moment Alice crosses the event horizon. So, once Alice crosses the event horizon, everything outside becomes her past, and whatever happens to her afterward will no longer have any connection to this universe. Even if she sends an outside signal, it will never reach its destination. Thus, although Alice is already dead, theoretically, Alice in Bob's eyes will forever live at the event horizon of the black hole. Fifth, the ant and the rubber rope paradox. Suppose there is an immortal ant, crawling at 1 centimeter per second, on a rubber rope that is 1 meter long. At the same time, every second, the rubber rope is stretched by 1 kilometer. So, can this ant reach the other end of the rubber rope? Intuitively, as the rope stretches 100,000 times faster than the ant, one might judge that the ant cannot reach the end. Using the harmonic series, we conclude that when the rope stretches at 1 kilometer per second, it means each half of the rope stretches at a speed of 0.5 kilometers per second, and the speed of each quarter is 0.25 kilometers per second. When we eventually divide the rope into 5 millimeter segments, the stretching speed of each segment becomes 0.5 centimeters per second. In this case, the ant at 1 centimeter per second can finish the first segment. When the ant reaches the second part, though the rope length has increased, the speed is still 0.5 centimeters per second. This allows the ant to complete it as well. And so on. When the ant finishes all segments, it will reach the end of the rope. The key to the problem is that the rubber rope stretches instead of just extending. As the rope is stretched, the ant moves along with the rope, and it is always able to complete each segment of the rope. Calculating with integration, we find that the time for the ant to complete the entire journey is 8.9 times 10 to the power of 43,421 years. This is longer than the time since the universe began. In other words, regardless of the rope speed, the moving speed of the ant or the length of the rope bar, the time required is always finite, and the seemingly counterintuitive ant on a rubber rope paradox implies human limits with complex concepts of time and space, and infinity, but also reflects on the infinite cosmic boundaries, and reveals the way we perceive the real world. Sixth, Pinocchio's lie. As everyone knows, Pinocchio's nose only grows longer when he tells a lie. But what if he suddenly claims, "My nose is about to grow longer now"? Then, will his nose grow longer or not? If it grows longer, it means what he just said was the truth. But the problem is, how can telling the truth grow his nose? If it doesn't grow, it means what he just said was a lie. Since it is a lie, it must grow. And it is precisely such a simple sentence that forms a self-fighting, endless loop from which there is no escape. Seventh, the color blindness paradox. Suppose there is a person who cannot tell blue from green since birth. The sky he sees is green, and the grass he sees is blue. But since childhood, adults taught him, the sky is blue, grass is green. So though the colors he sees differ from others, the names he uses are the same. In other words, though he can't separate blue and green, he will think that the green sky in his eyes is called blue, and the blue grass is called green, and he has no problem communicating with anyone at all. Then, how do you prove you aren't him? This color blindness paradox by John Dalton, in the 18th century. It not only challenges our perception of color, triggers epistemology debates, the nature of reality and individual perception. That is, if everyone's perceptual experience is unique, then is it possible that the objective world we see is not the same either? If that's the case, how should we define the essence of the things we perceive? As linguistic symbols made by humans, maybe to the colorblind, lies the true colorful world. Since no one can see through another's eyes, who can be 100% certain that what they see is the so-called real world? 8th, Olbers Paradox. If the universe is infinite, and filled with countless stars, then no matter which direction we look, our sight would eventually land on a star. In other words, the night sky should be full of light, and it ought to be as bright as day. Yet the reality is, the night sky is deep and dark. It is this contradiction that ultimately revealed the shocking cosmic secret, that the universe is not eternally static. It has both a beginning and an age, and it is expanding rapidly. Because its expansion exceeds light speed, it ensures that distant starlight will never be able to reach Earth. 9th, the infinite monkey paradox. British mathematician Arthur Eddington once proposed an infinite monkey theory in 1929, assuming a monkey is placed in eternal time and allowed to keep typing. After an infinite amount of time, it would eventually type all books in the museum. He believed the chance of a finite set in an infinite set isn't zero. And in our universe, all matter, including the human body, is composed of elementary particles. They are in random motion every single moment. So, after a sufficiently long time, will all particles in the universe likely return to their state at a past moment? If it really can, does this mean our universe is in a state of constant reincarnation? 10th, the Fermi Paradox. There are billions of stars in the Milky Way, and planets are counted in trillions. Even if life's chance is tiny, the universe should have interstellar cultures. Based on evolutionary speed, any advanced civilization would need only a few million years to colonize the entire Milky Way. We should have received signals long ago, seen countless spaceships, and the night sky should be bustling. Yet, the reality is that the universe is dead and silent, without any trace of civilization or alien visitors. Behind this lie three terrifying hypotheses. First, alien civilizations simply don't exist, and humanity is the first and only civilization in the universe. Second, a special filtering mechanism exists, where intelligent life is invisibly restricted during its evolutionary process, perishing at home due to an inability to become interstellar. Third, aliens discovered humanity long ago, but choose not to interfere. For example, in a pond, there is either a school of fish or none. If there is one fish, it indicates this is a fish tank. If alien civilizations do exist, they might be the ones watching the tank right now. In other words, the reason aliens are terrifying is not due to their scary looks, but because we have absolutely no idea in what form they exist, nor what they would do to humanity once they discover Earth.